This course means a lot to students because they get immersed in a real and honest-to-goodness research experience as undergrads. You don't get that at most schools. The idea behind this particular trip is to see if we can establish a correlation between the temperature at the surface of the sea ice and the thickness of the sea ice. The ultimate idea is to see if we can present a potential method to measure the thickness of the sea ice over a large area very quickly. And so the students are full participants in that research effort.
We're out here trying to measure the sea ice thickness with the OhmMapper resistivity survey. So basically, resistivity is a measure of a material's ability to resist the flow of electricity.
All right, let's go.
And the OhmMapper has a bunch of components on it that provide that electrical signal and some receivers, and that can give us a cross-section of what's happening in the subsurface.
The cold in Barrow is something I do not want to experience on an everyday basis.
Students have not experienced anything like this before because they're used to being in Radford, somewhere in southwestern Virginia. The extreme cold is about 10 degrees Fahrenheit. Maybe the wind chill puts it down at 0 degrees Fahrenheit. But you get up here, and the normal daytime high at this time is about minus 15, minus 20 degrees Fahrenheit. You throw on the wind chill on top of that, you get minus 35, minus 40 degree Fahrenheit.
Even right now, the wind is biting my face pretty hard, and this is a warm day.
The nice thing about this is you've got one faculty member and 9 students. So that means that I'm right there with them all the time throughout the week. They are the ones that are coming up with the ideas for troubleshooting. They are the ones that ask questions right there with me. I answer their questions directly. If I don't know, we gather around and we all figure it out.
One of the instruments we're using is Whistler. It was developed by Dan Blake and Southwest Virginia Governor's School. It is a thermal sensor that records the temperature of the ice along a path. So the idea that we have is that at thicker parts of the sea ice, the temperature will be cooler at the surface. And where it's thinner, we think that the temperature of the surface would be a little warmer. And we say that because we know the temperature of the water below the ice, and it's constant around negative 1.9 degrees Celsius.
The reason we care about the volume of the ice is simple. It's very easy to get the lateral extent of the ice, in other words, the east-west, north-south pieces of the ice. The thickness of the ice over the entire polar ice cap averages only about 5 meters, that's about 17 feet. The thing is, the polar ice cap, because it's so reflective, it is involved in the thermal energy balance of our entire planet. When that gets out of whack, we have extreme weather. If the ice disappears, the dark seawater underneath absorbs much more thermal energy from the sun. That thermal energy is inside our atmosphere. That thermal energy drives extreme weather. All of these extreme weather events are driven to even more extremes by an energy balance of our planet thrown off kilter. And the ice up here is important in maintaining the energy balance of our planet.
Some of the stuff that we want to investigate is ground truthing, and how we do that is with our ice drill. It goes 2 meters thickness, and we just hook it up to an electronic drill, and we just put it in the ground and we see where the ice meets the water. And it's a lot more direct way that we can actually see the accurate depth of the thickness of the sea ice.
Another aspect of this trip, which I think is one of the important aspects, is having educators work with scientists. That is something that is not very common, to give my education students a chance to actually go out and work with scientists. And when I say scientists, I'm referring to the students that are in the class, because that is what they want to be when they finish. Our main role on this trip, the education team, is to try to explain the research to children back home in Virginia.
This morning I woke up at 5 o'clock in the morning to go Skype with my students.
So it was our first morning walking over, and we saw the northern lights this morning, and they were really awesome.
While we're here in Barrow, we want to Skype with our students back in the classroom to try and bring those real-world connections to the classroom.
Okay, so now she's going to touch this soap bubble outside, and it's completely solid, and she poked a hole through it. You guys see that? It froze the soap bubble.
My passion is learning, and I really want to express that in a way that would influence my kids to become lifelong learners. And I think by showing them that I'm still learning and that I still have a lot to explore, I think is a great incentive for them to keep learning.
For me as an educator and looking at science, it is important to understand the whole picture. Not only to understand the science research and its importance, but also to understand the culture and how does the research affect the people that are here. So we started by going to an Inupiat daycare called the Language Nest. It is an immersion daycare where 2- and 3-year-olds begin to learn the language, the Inupiat language.
The community up here cares what we're doing because what we're doing will affect perhaps their future. So much of their lives do revolve around the whaling seasons and various other seasons. If the ice changes, the whales change, their lives change, their subsistence lives change. The students get an opportunity to process the data and to organize their thoughts and to tell anybody else around about the results. And it's an amazing thing. It gives them the ability to be able to organize what they did, look back quickly, and to really understand the data because they have to process the data and interpret it.
I think that the people in Barrow want to know what we're doing up here. Really, all the information that we can gather on the area can help understand how it's evolving and how it's changing.
I think the greatest thing about this class is that it doesn't stop at the end of this semester. After we go back, after we take our data back, we process the data. The students understand how to process the data truly and honest to goodness process the data and present it at a meeting. That will happen in mid-April at the Student Engagement Forum. But over the course of the next 6 months, I will work with the interested students and we will further process the data. We will present our work at the American Geophysical Union Fall Meeting in San Francisco. That's the world's largest collection of Earth and space scientists. And we are there next to people from NASA and NOAA, and they are critiquing our work. Our students are getting an opportunity to present their work in a forum beyond campus, an international meeting, and the people who are asking the questions of them have jackets that say NASA.